Hi guys. So the next lesson that we have to cover today is Catching Some Z's Revisited. This is going to help us cover what we do when we have two samples. So sometimes you won't always have one sample. So on your data sheet, when you recorded how much you slept that night, Mrs. Wilkes may or may not have done this with you, but you were separated into two columns, males and females. For the first day that we did this activity, we actually kept males and females. So when we went to stat edit, we typed all males and females into L1. Well, today, if you wanted to talk about, is there a difference between the mean hours slept for male students and female students, you would actually type them into two separate lists. So you could separate your female data here, your male data here. Regardless if you do this activity with Miss Wilkes or not, we can write our hypotheses for this. So if we want there to be no difference, that means we want them to be equal. So that means we want the mean that females sleep to be the same as the mean that males sleep. I'm just going to use F and M here, but off to the side, I am going to put that F equals female and M equals male, just so we have a nice little legend to say which one's which. Instead of saying like, oh, females sleep more or males sleep more, we could just say that we want to prove that there is a difference. So if you just want them to be different, that means we want the mean of females to not equal the mean of male. We don't care if they're any larger or smaller. We just want them to be different. The conditions, when you have two samples, you could check the conditions still, but for your conditions, you don't have to worry about checking those. Technically, you would check that both are random samples and that both are approximately normal. So you have to check that n greater than or equal to 30 or your box plot, or just see if they both state that it's approximately normal. But instead of doing that twice per problem, we're super nice to you. And for two sample problems, we actually let you always assume that the conditions have been met. So I guess you're welcome, because that's super nice of us, if you ask me. Like I said, when you type in your data, you would type it into L1 and L2 in your calculator. That's going to give you your t-test statistic and your p-value. That'll just be based off the data you have. And then you could write your two-sentence conclusion. Remember, we're still comparing the p-value to alpha, whether it's greater than alpha, which is 0.05, or less than or equal to alpha. And then you would tell us whether you had sufficient or insufficient evidence in order to get there. Now, one thing that's different is, yes, you're going to type in your data into L1 and L2, but instead of going to stat and then test, before we were going to your t-test, right, your number 2. Well, now we have a two-sample t-test. So that's why you would go down to number 4 instead. So for the calculations, just a little notes I'll make right here is that you would go to stat. You would arrow right over to test. But this time, instead of picking number 2, you're going to pick number 4 for two sample, because now we're going to have two samples to compare. And it's a t, right, because we're dealing with t distributions and we're doing hypothesis testing. So two-samp t-test. And that's how you'd go about that problem. But the reason I'm not going to do it with you on this video is because I have no clue what your class data ended up like. So, yeah. So since I have no clue what your data ended up like, let's do a couple examples together that would be the same for everybody no matter what happens. So on the bottom of page 7, which is where this lesson's at in your packet, we're going to do the first example, which is a factory hiring people to work on an assembly line, and they give job applicants a test of manual agility. This test counts how many strangely shaped pegs the applicant can fit into matching holes in a 1-minute period. A random sample of male applicants and a random sample of female applicants were selected. The table summarized the data by gender of the job applicant. So this is a nice little table for us to look at over here. Assuming the conditions have been met. Once again, if it's two sample, they're going to let you assume those have been met. So that's super nice. We don't have to check the conditions on two sample. But what we're trying to show is if there is sufficient evidence to say that there is a difference in the mean number of pegs that can be placed correctly for male and female applicants. So my hypotheses, the null hypothesis. Remember, the null is what you have to assume to be true. So we have to assume that the mean for females is the exact same thing as the mean for males. I'm actually going to go back and fix this because I'm going to put males first, only because males were first in my table. Okay, because the way you type in your data does matter. So the mean of males equals the mean of females. And once again, I'm going to go over here and make sure I do a nice little legend so that people know that M stands for male, S stands for female. If you don't want to worry about the legend, you could just write it all out. Mu sub male equals mu sub female. Then the alternative hypothesis, if I just want to show there's a difference, that means I don't care which one's bigger than the other. So I just want not equal to. Okay, so let's go over our calculations. Remember, for your calculations, you need a t-test statistic and a p-value. And I'll show you one where I have the calculator shade for us and one where it doesn't. And that way you can figure out which one you want to go with. So the first one, I'll have it shade for us. So I'm going to go to stat and then test. Oops, not z-test. So stat and then test number 4 for 2 sample t-test. This time I don't have data, I have the stats. So this is what I was talking about. Notice how they say X bar 1, standard deviation for 1, and sample size for 1. Which one you type in first matters. Since I put males first in my hypotheses, I have to type in the males first. Okay, so that does matter, so be careful with that. So my first mean for males is 19.39. My standard deviation is 2.52, and my sample size was 50. I put female second in my hypotheses test, so that's going to be my second set of data. So their mean was 17.91, standard deviation of 3.39, and a sample size of 50. And I'm just trying to show that they're not equal to. Anytime it asks you about whether to pool or not, don't even change that. Just leave it as no. And this one I'll hit draw. That way you can see the curve shaded as well. Remember, draw does take a little bit more time because it's shading the curve for you. But the t-score and the p-value will show up here at the bottom after it's done slowly but surely graphing. So this should make sense. Remember, not equal to is a two-tailed test. That's why they're shading in both the tails. So let's see. I get a t-test statistic of 2.478. 2.478 and a p-value of 0.015. So if I go to a t-score of both negative 2.478 and of positive 2.478, I would shade into both tails. Or not equal to, you shade into both tails. Okay, so now I'm ready to write my conclusion. Remember, your conclusion should always be 2 sentences, just like it was for 1 sample. So I'm going to say, since the p-value, in this case, it's less than or equal to alpha, because remember, alpha is 0.05, we reject the null hypothesis. And remember, you don't have to write this into your sentence, but this means that this is statistically significant. So if you are able to reject the null hypothesis, it is statistically significant. So then we need to talk about what is true about our evidence. So since the p-value is less than or equal to alpha, we reject the null hypothesis. So we have sufficient evidence to say that there is a difference in the mean number of pegs that can be placed correctly for male and female applicants.